Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Today, I'm going to start a new topic, which is trigonometry, which is basically the measurements of triangles. We are using that in triangles, and then later you'll see there is an ample you know, amount of applications for trig. So um, we use them here just to find, angles and sides and distances and heights. But later you will find that they have a lot of more involvement in science and engineering and math, of course. So let's stay away from memorization. The only thing I will ask you to memorize will come later today. But basically, when we look at the trig, we are discussing the relationships between angles and sides of a triangle. Okay? That's basically it. And because the right triangle is the easiest one, we are going to use it to show these six functions that we are talking about. So if I have a right triangle here, and let's call the sides A, B, and C, and well, I should have put A here because usually we refer to the angle opposite to the side with the same letter but with uppercase. So that would be B and that would be A instead of this being A, and that doesn't matter. But in fact, I'm going to call this theta. We will be using a letter theta or X for the angles a lot. Okay, so the first thing we know about the triangle, thanks to Pythagoras, is the Pythagorean theorem, a squared plus b squared equals c squared. So keep that in mind for now, okay? We define six relationships between an angle and the sides of a triangle. Why six if I only have three sides? Well, because I can divide A by B or B by A by C or C by A, B by C or C by B. So there are six quantities. Yeah, of course, three of them are the reciprocal of the other three, but they are six. Okay, so we define the first function as the sine, S-I-N-E, but we write it S-I-N of theta. The sine of an angle is opposite over hypotenuse. It's B over C. Okay? They will tell, oh, it's SOHCAHTOA. I don't I don't see what do you gain by memorizing that. But anyway, the sine is the opposite over the hypotenuse. The cosine, why do we call it cosine? If you break this word, it becomes the sine of the complement. And this angle is the complement of theta. So we call it cosine of theta. So in other words, I say, what is the cosine of theta? Meaning, what is the sine of this angle, the complement of it? It's still the opposite over the hypotenuse. We didn't do anything else. We said instead of saying adjacent, as you say, so SOHCAHTOA, no, it is the opposite of the complementary angle, meaning sine of the complementary is opposite over adjacent, over hypotenuse, the same thing. And then here's a relation we learn later is that the tangent of any angle equals the sine of this angle divided by the cosine of that angle. The sine of this angle is B over C. The cosine of this angle is A over C. So it's B over C times the reciprocal C over A. These cancel and I get tan theta equals opposite over adjacent. Okay? Now, the reciprocal of sine, meaning C over B, is called the cosecant of theta, is C over B. And the reciprocal of that is secant theta, or C over A. And the complement and the reciprocal of that is called cotan theta, which is A over B in this case. So these are the six. And you say, oh, how do I remember which is which? I tell you, it's so easy. The reciprocal, the two functions that are reciprocal of each other, only one of them has the prefix co. Sine, cosecant. Sine doesn't have a co, so the reciprocal is cosecant. Cosine, it has a co, so the reciprocal doesn't have a co, it's just secant. And the tan doesn't have, but the tan is easy because it's tan and cotan, so we know they are the reciprocal of each other. Okay? Maybe it's not time to introduce that now, but I'm going to say that if I add the square of the sine of each of any angle to its cosine, to the square of its cosine, what do I get? That's another way of looking at the Pythagorean theorem. Why? How? Well, if sine theta is b over c, then sine square is b square over c square. And because cosine of theta is a over c, so this is a square over c square. So when I add them up, I get a square plus b square over c square. But Pythagoras told me in a right triangle, a square plus b square is c square. So this becomes c square over c square, or 1. And that is a universal identity for any angle in the world. When you take its sums of sine square plus cosine square, you get 1. If you go to the other playlist of trig, I tell you this is not an identity. Oh, this guy is crazy. Get his degree back. He doesn't know anything. Wait. Don't jump to conclusion. I say this is a special case of a universal identity. Maybe it's not time for that now, but if you are interested, go there and see why I say that. Alrighty, so once you remember those, so these are like, when your multiplication table, you start memorizing it day after day. Oh, I memorize it. I'm good at math. Well, okay, you are. Um, Later on, nobody would start to remember, oh, what was 5 times 4? Unless you are relying on your calculator for everything. So this is the same thing. I'm going to, in the beginning, memorize what is the sine, what is the cosine. I didn't know what I'm going to do with these things, but these are like the building blocks, and they told me to memorize them. I'm not going to memorize them, but at least I know these three: opposite over adjacent, opposite of the complement over adjacent, and then opposite over this over that. And then later, I know that they have one of these two has the prefix co, not both. So the inverse of cosine is not cosecant, because this has a co, so the opposite would be secant, okay, or the reciprocal. Okay, having said that, we found some interesting angles that are easy to find their sine and cosine. So for example, if I tell you if theta equals 45 degrees, then my triangle is an isosceles right triangle, right? If this is 45, then that also is 45, which means the sine is the same as the cosine. It doesn't matter, right? The complement is the same as the angle. But the ratio of these three, first of all, since these two are equal, I can say, oh, this is 10 and this is 10, or this is 7 and this is 7. I would make it hard on myself. Why? I'm going to say this is 1 unit and that's 1 unit. Okay? And because of that, I use the Pythagorean theorem and I say if this is 1, so 1 square is 1, plus 1 square is another 1, so I get 2. C square is 2, meaning the square root of C square, which is C, is the square root of 2. And now I know these 6 values for an angle of 45 degrees. Sine is 1 over square root of 2, or some people, because they don't like uh, an irrational denominator, we multiply top and bottom by root 2 and you get root 2 over 2. Cosine is also root 2 over 2. Tan is 1. So the cosecant is root 2, because I'm going to divide the reciprocal of 1 over root 2 is root 2. Root 2 and 1. I already know the 45 degrees. Don't, yeah. And so what? What if it's 44? I will use a calculator, right? We also found another interesting relationship between a right triangle whose one angle is 30 and the other is 60. We found that the ratio of the opposite side is always half of the hypotenuse. Some people would say, well, why not 1/3, since 30 is 1/3 of 90 and this was 1/2, so you got, it's not even, so the square was 1 over 2, so why this is not 1 and 3? Well, it's the nature of triangles. If this is a unit, then this is 2 units. I can use the Pythagorean theorem and I say 1 square plus something square equals 2 square. So 1 plus something equals 4, so that thing has to be 3. And when I take the square root of that, I get root 3. So now I know the sine of 30 is 1/2. The cosine of 30 is the opposite of the complement over that, so root 3 over 2. And the tangent is 1 over root 3 or root 3 over 3. So now I know the 30. The 60 is the exact opposite. The sine is root 3 over 2. The cosine is 1 over 2. And the tan is root 3 over 1. So now I know 30, I know 45, I know 60. There are two interesting angles also that you may know, or you will know. One of them is the zero angle. You say, wait, what? Can you have a triangle with a zero angle? Yeah, and the other two are 90s. No. I don't get that. You mean a straight line? Yes. So is a straight line a triangle? Yeah. It is a triangle that has degenerated. I kept decreasing this angle, decreasing it until I'm going to draw it, of course, not a straight line. I'm going to do something that I enlarge it a lot and I say this angle is 0 degrees and this is 90. Well, if that's the case, then these two lines or two sides have the same length. So if this is 1, that would be 1. But 1 square plus something square equals 1, that thing has to be 0. Whoa. Yeah. So the sine of 0 is opposite over hypotenuse, it's 0. The cosine of 0 is adjacent over hypotenuse, which is 1. And the tangent of 0 is opposite over adjacent is 0. And someone would say, oh, but I can make this angle 90 degrees. And in that case, it's the same triangle, but I turn it over. So if this 90, then that also would be 90. So the sine of this angle is opposite over hypotenuse is 1. The cosine is 0 over hypotenuse is 0. But I have a problem with the tangent because the tangent is opposite 1 over adjacent 0. That's undefined. But at least I know. So these four triangles show me that I can find the sine, cosine, and tangent of 0, 30, 45, 60, and 90 easily. 5 values. Well, it's not bad, but we are going to learn more stuff that would allow us to do more of these. I can find half an angle, a double of an angle, and so on and so forth. But at the end of the day, I have a calculator and I have these three functions, sine, cosine, and tan, so it's not a big deal. But I wanted to introduce those. Notice that up to till now, we are talking about a triangle that has angles between 0 and 90. So all the angles that I dealt with, except this one, are acute angles. What if I have an obtuse angle? Or what if it's not a triangle, I have some other angle that is more than 180 degrees? What, can that happen? Yeah. So mathematicians said, let's introduce this topic differently. We are going to draw a circle and we call it a unit circle. A unit circle meaning its radius is 1. Unit meaning 1. Oh, I hate this thing. I need to buy a new compass. This one doesn't, I don't see even where, I don't see the, let's try, okay, let's try another circle. Hopefully this one would, okay, so I hope you can see it. It's very light. I'm going to divide this circle into 4 quarters. We call them quadrants. So this is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. So the angles, this angle is 0. I'm going to start counting from the horizontal positive x-axis going counterclockwise. So that would be 90, that would be 180, that would be 270, and that would be 360 degrees. Oh. Okay. So now, if I draw my triangle in the first quadrant, we always going to draw it going from the center to the circumference of the circle and say this is my angle theta. If I am in the second quadrant, I'm gonna draw it again from here to here, and that is my triangle. And in all cases, my hypotenuse is 1. If I am in the third quadrant, so that would be the theta. If I am in the third quadrant, well, I'm not drawing, well, since I called it theta, so they have to have the same measurement. Theta, and this is 1. And finally, I have another theta. And this is 1. So notice carefully that if I am in the first quadrant or the fourth quadrant, the x is positive, right? This side is positive. And if I am in the second or the third, the x is negative. On the other hand, if I am in the first or second, the y is positive. And if I am in the third or the fourth, the y is negative. Okay, we define the sign as opposite over hypotenuse. So if I am in the first quadrant positive, the radius is always positive. You cannot have a negative radius of a circle, right? So positive over positive is positive. The cosine is adjacent over hypotenuse is positive. The tangent is opposite over adjacent is positive. So everything is positive. We say all positive. So in the first quadrant, all. If I am in the second quadrant, the sine is opposite over hypotenuse, positive. The cosine is adjacent over hypotenuse, negative. The tangent is sine over cosine is negative, or opposite over adjacent is negative. So only the sine is positive. When I go to the third, sine is opposite, negative, because I'm dividing by a positive. Cosine, negative. The tangent is opposite negative over adjacent negative, so it's positive. Only the tangent here is positive. And finally, in the fourth quadrant, opposite over hypotenuse is negative, so the sign is negative. Cosine is adjacent over hypotenuse, that's positive. And tangent is negative over positive, so it's negative. Only the cosine is positive. Of course, when I say only the cosine, I mean the cosine and the secant, only the tan and the cotan, only the sine and the cosecant, right? Because the reciprocal of a positive is positive and the reciprocal of a negative is negative. Some students, again, use a mnemonic to remember that. All students take calculus. I hope you take calculus. All students take calculus to remember, okay? It turns out, you see, for example, if theta is 30 degrees, I know the sine, cosine, and tan. Easy. But if theta is 150 degrees, as a magnitude of the sine, cosine, and tan, theta and 180 minus theta, or 180 plus theta, or 360 minus theta, all of these four angles have the same sine, cosine, and tan as an absolute value. Wow. So that's a quick way to remember how to find the sine, cosine, or tangent of not only the 0, 30, 45, 60, and 90. No, I can have also the 120 and the 135 and the 150 and the 180 and the 210. I can know more than that, right? In fact, I told you I hate memorization, but this one maybe in the beginning would help you remember these functions. So I'm going to say maybe here I can write sine, cosine, tan, and then cosecant, secant, and cotan of the angles we remember, the angles that we know, okay? And the angles we know are the 0, the 30, the 45, the 60, and the 90. And next to those, so this is theta. And here I'm going to write something else. I'm going to call it n. Okay? And here I'm just going to number these in increasing order and starting with 0. 0 matches with 0. And then 1, 2, 3, and 4. Okay? It's easy, right? To just create this table. Okay, so how do I calculate the sine? We already know sine of 0 is 0, but the way we are going to do it is to say, take the square root of n, whatever n is here, and then divide it by 2. Okay? So square root of 0 is 0, divided by anything, it's 0. Square root of 1 is 1, divided by 2 is 1 half. Square root of 2 is square root of 2. I cannot simplify. Divided by 2 is square root of 2 over 2. Square root of 3 over 2, because that also cannot be simplified. Square root of 4 is 2. Divided by 2 is 1. Wow, I found the sign. And once you find the sign, the rest is history. Why? Because cosine, I'm going to write them exactly the same, but backwards. So really, you don't need to memorize. If you know the sign, then you divide sine over cosine, right? I divide 0 by 1, I get 0. I divide 1 half by that, the 2 cancel, and you get 1 over root 3, which some people prefer to write it root 3 over 3. This over itself is 1. This over 1 half is like multiplying by 2, so the 2 and the 2 cancel, and you get root 3. This is 1 over 0, so it's undefined. You get infinity here. Cosecant is 1 over sine. So the reciprocal of what? 0, 1 over 0, again undefined or infinity. This over that, you multiply by 2 over, you take the reciprocal of that, so you get 2. You take the reciprocal of that, you get 2 over root 2 or simply root 2. You take the reciprocal of that is 2 over root 3. Some people prefer to multiply top and bottom by root 3 is to you get irrational denominator, and 1 over 1 is 1. The secant is 1 over cosine. So I take these and reverse them. Or I can write these backwards, like we did with the sine and the cosine. So I write 1 here, then 2 root 3 over 3, then 1 over 1. Oh, I'm doing the cosine. Yeah, I said let's write them backwards. So this is square root of 2, this is 2, and this is undefined. And finally, the cotan is 1 over 10. 0, so undefined. This is 3 divided by root 3, which is root 3, or for the 10 and the cotan, you can also write them backwards. So you say square root of 3, 1, square root of 3 over 3, and 0. I found these 5 angles, and if they are in any quadrant, I can find them. So I pretty much know the sine, cosine, tan, secant, cosecant, and cotan of 20 angles within the circle. Okay? Now, what I also want to say today as an introduction is the following. So we have something called terminal angles. What do these mean? Co-terminal, meaning they terminate at the same point. Do you see that if I say theta here, let's say theta is 20 degrees. If I add 360, I get 380. These two angles, 20 and 380, are coterminals because they end up, when I start from here, 90, 180, 270, 360, 380. I end at the same point as 20. So if I have an angle, I can add or subtract, if I rotate in the opposite direction, multiples of 360, and we call them coterminal angles. Because if someone asks me, what is the sine of 750 degrees? I don't need to use a calculator. Why? Because if, first of all, well, you can use it if you want. I take this 750 and divide it by 360. I know that 360 times 2 is 720, meaning I would go two full circles which don't match, don't mean anything, don't change anything. So if I subtract 720 from that, I get 30 degrees, and the sine of 30 is 1/2. Okay? So if this number is positive, greater than 360, you can divide that number by 360, and you get, for example, 3 point something. So you subtract 3 times 360. What I mean is the following. Suppose I say, what is cosine of 1500 degrees? I'm going to use my calculator and say 1500 divided by 360 is 4. So I can subtract 4 times 360 from the 1500. That gives me 60, so that's cosine 60, and that's 1/2. What is the tangent of 1935? No, it's not the year I was born. I'm not that old. Okay, so I'm going to divide 1935 by 360. I get 53 and 3/4. Oh, I'm sorry, 5.375, right? 5 point, I divide by 36. So I'm going to say 1935 minus 360 times 5, because it's 5, not 53. I get 135. So equals tan of 135 degrees. Oh, 135. If this is 90, you see this angle is 180 minus theta. So 180 minus 35 is 45. But it's in the second quadrant, and it's a tan. Only the sign is positive in the second quadrant. So I say negative because I'm in the second quadrant. But as a magnitude, this is the same as tangent 45 degrees, and tangent 45 is 1, so I get -1. It may be a problem if I give you a negative angle. Suppose I say, what is the sine of -240 degrees? Oh, in this case, I'm not going to divide or by 360. Or I'm going to divide by 360. Of course, if I divide by 360, I get 0 as 0 and then -2/3, right? I get 0. So you add 1 to that. So when it's negative and you divide by 360, you add 1. Here we didn't add anything. We just subtracted. But if it's negative, you divide by 360, you get 0. You add 360, you get sine 120. Sine 120, we are in the second quadrant because between 90 and 180, so that's positive. And 180 minus 120 is 60. So this is sine 60. And sine 60 is √3/2. Let's take another one because I told you we have to add one. So let's say, what is cosine of negative, let's say 960 degrees. I'm going to divide 960 by 360, so I get 2 and something. So I'm going to make it 3 instead of 2 and say 3 times 360 minus 960. So you see, I had to increase 1 and then subtract or add. I add a negative number, meaning I subtract 960. I get 120. Oh, same thing. Cosine 120 degrees. Cosine in the second quadrant is negative. Only the sine is positive. All students. Okay, so that's negative. Cosine 60, because if it's 120, you get 60, right? Cosine 60 is 1/2, so I get negative 1/2. It's really very easy. Let's make sure I am the mode in degrees. Yes, I am in degrees. This is something you have to make sure if you are working with degrees or radians that I'm going to discuss. I know it's a long lecture, but it's really long session. But if I say sine 750, just checking our answers, I get 0.5. Cosine 1500, I get 0.5. Tan 1935 is -1. Sine negative 240 is this number. And what is it's positive? What is square root of 3 over 2? It's the same number. What is cosine of negative 960? Negative 1/2. The last thing I wanted to talk about here is what are radians? To my surprise, I asked this question to many students and I never got the correct answer. What is a radian? A radian is another measurement of angles other than the degrees. Okay, but that doesn't explain what a radian is. I know, bear with me. If you draw part like a piece of a pizza, right? A sector of a circle, with radius r in such a way that the length of the arc here inscribed by this angle is also r. What? Yeah, you can measure it. You can get a rope or a piece of wire and you make sure that it's the same. So if this radius is 5, you cut a wire of length 5 units and you make it along a circle and you say, okay, it ended here. So you cut this piece of the circle. So you have that. We call this angle 1 radian. It turns out to be about 57.3 degrees. But 57 point, what does that even mean? It doesn't mean anything. It's just a measurement. But if I complete the circle and I wanted to see how many radians do I have? So this is another, this is the third, this is the fourth, this is the fifth, this is 6. It turns out that 360 degrees equals 2 pi radians. So it's another measurement for which 180 degrees is equivalent to pi radians. So if I measure in radians, I get pi. If I measure in degrees, I get 180. So 180 degrees, if I want to switch an angle from, if I have an angle like, for example, 120 degrees, and I say how much would be in radian mode. So I'm going to multiply it by pi and divide it by 180. The degree and the degree cancel, of course. The 0 and the 0 cancel. I divide by 6, I get 2. I divide by 6, I get 3. So it equals 2 pi over 3 radians. But if I have it in radians, so I have 3/4 of a pi. I'm going to multiply 3/4 of a pi and pi times 180 degrees over pi because they are equivalent. So the pi and the pi cancel. 180 with 4 would be 45. 45 times 3 is 135 degrees. So it's just another measurement. Like we go from kilogram to, or from Newton to pound, or from any measurement to another. Okay, once you know the relationship and the meaning of pi. So when I ask you what is pi, they say 3.14. How many decimal places do you know? I say, I don't care. I'm not asking what is the measurement of pi. What is the number pi? Where did it come from? It came from here. By measuring half. So when we make 1 radian, we got pi radians in 180 degrees. And that would be important next time when we start, we have a session of just easy stuff like that and trying to find the angles quickly and, with the sign, positive or negative. That's what we do next session. Until then, I wish you all the best and thanks for watching.